As I said, this is not a very time-consuming lesson. It goes pretty quick. But the concepts involved are very, very important. And we start off with examples in this lesson that are fairly basic and expect students to be able to apply those basic things they've learned to more complicated situations. We're going to be looking at what are called the laws of logarithms today. And just like there are laws of exponents, like, for example, with exponents, we have certain rules. We know that if you have r to the m and you multiply by r to the 3, you get r, I don't know where that came from. You get r to the m times r to the 3, you get r to the 3 plus m. We know that there's this rule that you have to add the exponents when you multiply a common base. And in grade 10 and 11 and earlier this year, I explained why that rule exists. We're beyond, though, the whys at this level. So there are rules that tell us how we treat logarithms. There's what's called a product law, a quotient law, and a power law. And they are all on your formula sheet. They are all, in fact, formulas. The product law, and I want you to listen carefully to what I'm saying as I highlight things. The product law tells you that the logarithm of a product is equal to the sum of the logarithms. The logarithm of a product is the same as the sum of the logarithms. The quotient law says the logarithm of a quotient, so a logarithm that's a single logarithm, but it's of a quotient, which is something divided by something, is the difference of the logarithms. And before we go on, I want to point out that when you add things together, order is unimportant. Log base b of m added to log base b of n is the same as log base b of n added to log base b of m. But when you subtract, order is important. And I want to point something out to you that will be helpful for later. And I'm going to remind you of a word. The word for what is in brackets here is the argument. When I take the square root of r, r is the argument. The sine of 30 degrees is the argument. The logarithm of m times n is the argument. I want to point out to you that the logarithm, I'm looking at the quotient law now. I want to point out to you that in the quotient law, the logarithm that is positive has the argument that was on the top, and the logarithm that is negative has the part of the argument that's on the bottom. So when you have an argument that's on the top of a fraction and you peel that single logarithm apart into a whole bunch of logarithms, if the part of the argument was on the top, then it's a positive logarithm. And the most powerful one, and I always say that, and then as soon as it comes out of my mouth, I go, I really didn't intend to make any kind of pun here. The most powerful one, the one that is the most useful, is called the power law. And it says that the logarithm of a power, which is a base to an exponent, is the same thing as taking the exponent times the logarithm of the base. We are allowed to move this exponent out in front, and we get the same result. So very quickly here, if I wanted to demonstrate this to you and what it means, I could figure out what log base 5 of 20 times 11 is, and seeing as how I have my TI-84 calculator here, I can actually do that. I can go log base function. It's a base 5 logarithm of 20 times 11 is 220. You can trust me on that. Log base 5 of 220 is this number. if I take log base 5 of 20 and add log base 5 of 11. What did I do there? Oh, I got way too many brackets. Sorry. See, I'm not used to this. I am not used to this at all. You guys are probably laughing at me because this is so simple for you. I guess I'm going to have to do this. Okay. Log base 5 of 20 plus. See, I'm like a grade 2 student all of a sudden because I can't figure this out. Plus log base 5 of 11. I could have done it quicker with the change of base formula. You get the same answer. Okay, I hope you get the idea. You know, you could do the same thing. You could try this on your own. Take log base 4. Don't do it right now, but take log base 4 of 82/3, and then take log base 4 of 82 minus log base 4 of 3. You're going to get the same thing. I do want to talk about this one. Log base 8 of 7 to the 3 is 3 times log base 8 of 7. This is a really, really important one because if you try to calculate it, I'll give you a specific example here actually. Let's calculate log base 4 of 2 to the 10,003. Okay? This is a classic, actually I better just go 1,003. This is a classic numerical response question. This is equal to what? And what students will do, we'll go with the TI-84, is they'll pull up that function and go log base 4 of 2 raised to the 1,003, and you get an error. And the reason you get an error is 2 to the 1,003 is too big for your calculator's memory. But I can move that 1,003 out in front using the power law, and log base 4 of 2 I should know is 1/2, because 4 raised to the half gives you 2. So I can now calculate this. This is the whole reason logarithms were invented by Napier over 500 years ago. It was so that we could do numerical calculations quicker. All right, let's dive into the examples. Write each expression in terms of individual logarithms. So I'm going to rewrite this with a set of brackets, and I'm going to put a multiplication sign there. What we have in question A is the logarithm of a product. Okay, a logarithm of a product is equal to the sum of the logarithms. What I'm using here is this formula from your formula sheet. The logarithm of a product is the sum of the logarithms. And then what I'm going to do is I'm going to rewrite it as 2 log base 3 of x, no need for any brackets there, plus log base 3 of y. I forgot my base 3 up here. I suspect that for some of you right now, and most of you eventually, you will go from that, all of you eventually should be able to skip that middle step. And I want to point out one last thing. I could have pointed this out to you yesterday. The y and the log, the x and the log and the 2 are all written on the regular line, on the regular text line. The 3 is a subscript. And if you go up to the very top, the 2 was a superscript. So you have this central body of text, you have a superscript here, whoops, and you have a subscript here. But any questions with A? How many of you, by typing yes into the window, see that the answer to B is log base 6 of x minus 3 log base 6 of z? I mean, ideally, that's the goal. This is my philosophy, and I've thought about this before. In the time that it takes you to prepare to write this, using the quotient law, your brain has already looked at this thing and said, oh, I can move that 3 out in front. But you can certainly put that step there if you like. Any questions with B? All right, C? Well, this is log base 2 of xy cubed minus log base 2 of z squared. It's a quotient. It's this on the top. So when we break it apart using the quotient law, we get that. But the top is a product. So when we break it apart, we get log base 2 of x plus log base 2 of y cubed minus log base 2 of z squared. And I really suspect, how many of you would have moved those exponents down first chance? Meaning type yes if you would have moved those exponents down as you were writing this stuff. You know, when I look at this, I see 2 log base 2 of z. So that's where we end up. We end up with log base 2 of x plus log base 2 of y times 3 minus 2 times log base 2 of z. And I want to point out to you that in that original argument, we had 2 pieces that were in the numerator, and both of those pieces end up producing positive logarithms. We had 1 piece in the denominator, and that one produced a negative logarithm. So you could have just gone right from here directly to the answer. Let's try D. D is one that people, even though I hope nobody gets it wrong right now, even after my further explanation, some of you will get this wrong. And it's because when you look at this, I don't know the exact reason, but you fixate on this multiplication that's on the bottom. And you end up saying, well, it's log base b of x to the 4. And again, I have to fight not to write 4 log base b of x. I just want to put that 4 out right away. And then they go minus log base b of y to the 10, z to the 3. And they may not actually write this step, but they have it in their brain. And then they continue, and they go minus log base b. And they say, well, this is times, so it's going to be y to the 10 plus log base b of z cubed. How many of you know that's wrong by typing yes? Yeah, I distribute the negative sign. You know, we're subtracting this whole logarithm, and the whole logarithm is that. So you have to use the distributive property of subtraction. you have to distribute that negative. I guess it's the distributive property of multiplication because we're multiplying by a negative. So we end up with log base b of x to the 4. And the fact that I haven't written that 4 out in front is driving me crazy. But minus log base b of y to the 10. Look how everything is either subscript, superscript, or normal script. Minus log base b of z cubed. Having said all that, this is why I gave you the rule that if the thing is on the top, it's going to produce a positive logarithm. If the thing is on the bottom, it will produce a negative logarithm. These are both on the bottom, so they're both negative. I don't think you need to do any of the other stuff. Now, of course, we move stuff in front, and we're done. Well, stuff. There's a highly mathematical word. We move the stuff in front. No, we move the exponents in front. 4 log base b of x minus 10 log base b of y. Again, trying to keep everything neatly aligned. Minus 3 log base b of z. By the way, we talked about this yesterday. All of these arguments cannot be negative. So occasionally you will see stuff like this. You cannot take the logarithm of a negative, and you cannot take the logarithm of 0. Aiden, you're asking about just distribute it. This is something, if I catch your drift, you're saying, do you need to do this, or isn't it better not to do it? I would agree. I would never do this. I would never actually do that. I would have just said, if I'm subtracting both parts, and I would have jumped from here to here. I don't think there's a better way. How about this? It's your decision. And nobody is going to penalize you on a written response, even if you went, well, I think all this is unnecessary and everything else is necessary. I know you probably want to move those exponents out and separate them at the same time, but how, your question is, how do we decide what's negative? You don't have to show any of that work. Am I answering your question? Oh, I understand what you're asking. Now I got it. This is what we want. We do not want to have, this is not wrong, but you do not want to leave your answer that way. No, you want to distribute that negative to get a final answer. Have I answered your question now? Yeah. I mean, could this be a choice on a multiple choice? I suppose it could. I've never seen it, though. All right, let's try one more. I would just throw out to you this question. How many of you see that this will be log base 7 of x, and it's multiplied by a third, minus 1/2 log base 7 of y? How many of you see that? The idea, so this is the thought process that's going on in my head. It's log base 7 of the cube root of x minus log base 7 of the square root of y. But we should know at this level that a cube root is an exponent of a third. This set of brackets I just put here is pretty important. Sometimes they don't get put there, but they should. Minus, this is log base 7. You should know that a square root is y to the half, and then you move those exponents out in front. I think you're getting the drift here. Number 2, use the laws of logarithms to simplify and evaluate this. I can look at this, and I'm really curious. How many of you see that that's equal to 3? And if you don't feel bad. Does anybody see that it's equal to 3? What about if I did this? Yeah, it's starting to, with enough thought, what about if I did this? It's a difference of separate logarithms, so I'm going to pack them together as a single logarithm. Now, the reason why maybe this is an unfair question is, and this is not, don't take this as an insult, but you as a generation of students are very dependent on your calculator. So myself, I look at 40 over 5 and I see 8. I don't even have to think about it. 40 over 5 is 8. Because, I mean, we had that every day in math class for years and years. Times tables, times tables, times tables. So this is log base 2 of 8. But everybody should know log base 2 of 8 is 3. My first calculator, I was allowed to use one in grade 9, and it didn't even have a log key on it. This would be log base 3 of 45 times 15 over 25. And what I'm about to show you is not just me saying, oh, this is the way math should be taught. There is value for you later on in this course and unit in being able to figure out what this is without a calculator. And some teachers would teach it to you differently. I'm going to do it by reminding you to help you out in the next unit by reminding you that when you cancel, how many of you were taught to do stuff like this? Don't write this down. You go, well, divide by 5, divide by 5, divide by 5, divide by... How many of you were taught stuff like that? Yeah, it's a bad thing. It's not really, it's messy, and I'm not a neat freak. That's not what this is about. It's messy, and messy is easy to make a mistake. Plus, you don't understand what's going on. If you take 45 and write it as all of its factors, 45 is 9 times 5, and 9 is 3 times 3. 15 is 5 times 3. 25 is 5 times 5. I've told you that you are allowed to cancel as long as you cancel a factor. So we have a factor of 5 and a factor of 5, a factor of 5 and a factor of 5. What you are left with is log base 3 of 3 cubed. And you know what? You shouldn't even need to figure out what 3 cubed is to know the answer to this question. To what do you raise 3 to get 3 to the 3? Well, you raise it to the 3. So this is equal to 3. Interestingly enough, everybody, if I take this log base 3 of 3 to the 3, I can move this 3, pardon the pink, I can move that 3 in front and have 3 times log base 3 of 3, and you should know this is 1. Because log base 3 of 3 is the exponent to which you raise 3 to get 3, which is 1. No matter how you cut it, you're going to get 3. What about this one? This is a little dirty here with the minus the brackets. This is log base 8 of 48 plus log base 8 of 4 minus log base 8 of 15 plus log base 8 of 5, because I'm subtracting a negative. When we pack all this together, we'll have log base 8, and on the new argument across the top, we'll have 48 times 4 times 5, and on the bottom we have 15. because the 48, the 4, and the 5 are all arguments of positive logs. I won't do the factor tree thing here. I would like everybody to figure out what, I think it's going to be 64, what that stuff in brackets works out to be. Is it 64? Okay. So we end up with log base 8 of 64, which you should know is 2. You shouldn't need to use your calculator to figure that out. You should know 8 squared is 64. D, well, these are all positive logarithms. So we're going to have log base 21 of 7 times 9 times 1/3. Let's see, 9 times 1/3 is 3. 3 times 7 is 21. Any questions with D? All right. E, this is log of 5 squared plus log of 20 squared. We cannot put separate logarithms together unless they have coefficients of 1. So what I've done is I've used the power law here, and I've moved this exponent, well, this coefficient up as an exponent, this one up as an exponent. So this is log of 5 squared times 20 squared. And I believe that you are going to get, is it 10,000, am I right, for what's in brackets? Okay. So by typing yes, from now on, you guys, I know I should have told you this before, and we've only got one more week of this, hopefully, when we get back. When I say how many of you, I'm looking for people to type yes. Thank you. How many of you know what this is as an answer? What does this equal? That's what I'm asking. Don't type what it's equal to. Just, it's 4, right? Because this is base 10. So this is saying, to what do you raise 10 to get 10,000? Of course, you could use your calculator. And how many of you see that this is 0? Give that a little bit of thought, a little roll around in your head. I mean, I look at this and I immediately see 3 log x minus 3 log x. Well, that's 0. Some people might see log of x cubed minus log of x cubed. And that's 0. Some people, and you might be one of them, some people look at this and don't see 0 yet. They do this. This is log of x cubed over x cubed, because I divide the arguments, which is log of 1. And that is saying, to what do I raise 10 to get 1, which is 0. As long as you apply the math properly, you will not get an incorrect answer. All right, now we're going to finish this off by looking at putting things together as a single logarithm. We start off with a very simple example. However, a multiple choice that people pick. And every time I give this exam, I turn the page and I start marking and I go, oh, please don't pick that. Oh man, you picked it? That is wrong, okay? This is not correct. People see this and they see log of y times z. But it's not subtracting the whole thing, it's subtracting the 1. You simply use the rule that I gave you, which says if you have a positive argument, if you have a positive log, that argument goes on the top. This is the answer to that question. And I think you can see it better if I rewrote this as log of x plus log of z minus log of y. Those are all base 10 logarithms, by the way. This one would be log base 2. What do we have on the top? We have an x on the top, because this is a positive log. We have a 2x on the top, because this is a positive log. We have an x squared on the bottom, and we have a y on the bottom because they're negative. The x squared on the top and the x squared on the bottom cancels, and you're left with this. And now, unfortunately, there's a twist. I hope that everybody remembers when we dealt with trig, you could do things right and get an answer, but it's not the answer in the question that they're looking for. They're looking for a different disguise. I don't know. I don't know how many of you will see this, but the question is, how many of you see this as the following? I bet you most of you would see it if I took this single logarithm that I'm pointing at right now. Just want to make sure my mic is still going. I'm on my last bar on my battery, so give me a second here. I'll change it in a second. I can rewrite that to log base 2 of 2 minus log base 2 of y, because the logarithm of a quotient is the difference of logarithms. That log base 2 of 2 is 1. Think about that while I change my battery. Any questions with that example? You guys are still hearing me, right? Okay, good. A couple more quick examples and then we'll be done. Again, you don't have to do this in one shot, but how many of you see that it's log of x cubed root y? Right? I mean, we bring these two coefficients up and you have log of x cubed. These brackets are pretty important. Plus log of y to the half. You should know that since you're adding the logarithms, you multiply the arguments. And you should also know that the square root of something is the same as a power of 1/2. And finally, this one. Sometimes it is what it is. There's nothing you can cancel here. I put this in here because I don't want people to believe you could do something wacky like the following. You do this, like I said, send Mr. Flynn an email showing him that you're doing that math and you'll cause him to have this big vein in his forehead. You can't do that. You can only cancel factors, and the factors are in brackets. So that's it, we're done. That's not bad. I figured we'd have about 15 minutes left. You can see what the assignment is. The assignment is on page 31. By the way, there's a lot of extra practice with logs and exponents attached to this handout. So 1 to 6 and 10 to 17 is what you're working on, plus those 5 problems, I believe, from the previous section. You're here for another 15 minutes for sure. I will try to be here till at least 3. I got a couple things. I might have to leave a few minutes early, but I will try to be here until 3. I always try to say goodbye when you leave, when I see you leave, but sometimes I miss the fact that you've said something and you've left. So in case I do that later, I hope that you guys have a really, really good break and a great Christmas, and you use the time to energize, but make sure you do a little bit of math in there. It's not easiest to learn under these circumstances, and if you don't do anything for 2 weeks, you'll lose what you have learned. So do some review on trig, do some review on the logs and exponents. Those are the big items here. Anyway, I'll shut up and let you get to work. If you need help, let me know.